Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will continue understanding factors of polynomial, which is also called remainder and factor theorem. This is video number 3. The link of the other two videos is in the description below. So we'll start with the understanding of division of long polynomials long division, because we will connect it with the factor theorem. So in this video, we will see what is factor theorem. So this is a long division question. Polynomial is given to you. The polynomial of degree 3 here in the numerator is divided by the polynomial of degree 2. And you have to bring it into this form. We have seen in the previous video that when it is written like this represents quotient, this represents remainder, and this represents divisor, right? Just like a number system, if you have, for example, 7 divided by 2. So after doing this long division, if you want to change it into mixed number, how do you write it? 3 whole 1 upon 2, which can also be written as 3 plus 1 upon 2, right? So exactly like this in the polynomial, this shows your quotient, like here 3 is a quotient, remainder and divisor. So because the purpose is not to teach you here long division, we have already done this in the previous video. So I have done this here directly for you. Let me show you. Okay. So now in this video, we will see how we will write it. So seeing this long division, can you write it in this form? Okay. So your times is up. Let me show you here. So this is my quotient, so it will come in place of ax plus b here. Then this is my remainder, which I have written here in this form, and definitely denominator is my divisor. So this is important factor and you have to remember this. So let's continue the factor theorem. So what is the difference between applying factor theorem and doing the long division method? So sometimes the question is given to you like this, and they ask you, find out if x minus 2 is a factor of this polynomial or not. So rather than going through this long division and finding the remainder 0 in the bottom, you can apply factor theorem directly. So let's see what it is. Here you can see this was the polynomial given to you and this was the divisor. According to factor theorem, you take the value of x from the divisor. Right now my divisor is x minus 2. If I put it equals to 0, I will get the value of x 2. This value of x I will substitute in my dividend, which is the polynomial which I am dividing it by. So it is x cube. Instead of x, I will replace it by 2. So all the places which are by x occupied, I will replace them by 2. So after this, let's use the calculator and do it. 2 power 3, 8. You can use calculator directly here and write down the value directly, right? So first substitution is the important step, but after that, it is not necessary that you show all these steps. So let me get the calculator and let me do it directly here as well. So I got here 0. So when you get the remainder 0, it means this, this represents what? This represents remainder. Now I got my answer 0. It means my remainder is 0. Then 2 is the root, which means x minus 2 is the factor of my polynomial, which was f of x. You understood? So this whole thing, f of 2, is actually giving you remainder. Please remember this very important thing. And in it, the value of x gives you the factor. Okay. So now let's quickly find out if this is a factor or not. So what is the first step you will do? From x minus 2, you will get the value of x. You got it 2. By chance it is again 2. It's not necessary that every time it will be 2, right? and the function which you have to, polynomial which you have to divide it. So give it a name. For example, I'm giving it a name of f of x. So f of x is equals to, because it is very important that how do you present your work, right? So now you will substitute 2 in it and you will see if your answer comes 0 or not, right? So let's check it. 8 plus 4 minus 8 minus 4, I got 0. So because I got it 0, it means what this implies? This implies x minus 2 is a factor. This is what we had to show, right? Now, it is very important to understand the general form of it, because when you are reading books, you should understand how to read and what to comprehend out of it. So instead of f of x, you can use any name. You can use g of x, you can use h of x, you can use p of x. Like in this question, it is saying your polynomial px is divided exactly by x minus c. Here I took in the question x minus 2. Now they are taking it as x minus c. So what is the value of x? C, right? You should understand when it is written in terms of algebra, letters. So now q of x is your quotient. Okay, so if I write it, I'm again telling you it's very important to understand this language, because that will make generalization of the concept. Quotient will come here and then your remainder is here. So what do we get from here? Do you get this thing or not? P of x is equals to x minus c times q of x. For those who are finding this concept difficult to comprehend, they can try to link it with this. For example, if I say 2 times 4 is 8, so I can say 8 is equals to 2 times 4. Similarly, p of x is equals to x minus c times q of x. Okay, so now you can again test your knowledge. I have solved this question here very quickly, just as a recap, and you can see how you will write it. So if somewhere in the question, it is in the past paper as well, if this is given to you, right, and this is not given to you here, it means very clearly that x is equals to 3, which means x minus 3 is a factor. Why? Because this gives you remainder. So in the next video, we will see the remainder theorem. So this is the understanding of the factor theorem, and we will connect remainder theorem with the factor theorem. The link of the next video will also be in the description below. Thank you very much for watching. Please